Happy Friday, everybody. It's May 1st, even though it feels like one, not a Friday, and it doesn't really feel like May right now. You need to have out Unit 13 note packet to page 10 in a reference table. So down here, this is Joe Exotic. If you have not watched Tiger King, highly recommend. A great waste of time and brain energy. You don't have a new skill check tonight. Just as a heads up, you are going to have a quiz next Tuesday on everything we've done for acids and bases so far. Today, what we're going to do is we're going to do the second theory of acids and bases. Monday, you are going to do some practice whiteboard problems and have a skill check. And then Tuesday will be your quiz. So you'll be prepared. Please write any questions or comments in the questions discussion for that day. Also make sure you're reading the comments on the skill checks I'm writing. I'm writing how you should be doing problems, what you did wrong with the problem. So hopefully that helps you along the way. But yesterday, we were talking about the Arrhenius theory of acids and bases. And remember, a theory is kind of just a way to kind of define what an acid is and what a base is. You don't have to write this down anywhere. But the Arrhenius theory said that acids produce either H+, which is a hydrogen ion, or hydronium ion, as the only positive ion when you put it into solution. That was our definition of an acid. Now, bases, on the other hand, produce a hydroxide ion, which is an OH minus ion, as the only negative ion in solution. So that was just one way that you can define an acid and define a base. It's based on what type of ion they produce. If it's an acid, it produces H plus or H3O plus. If it's a base, it produces OH minus. So you want to make sure you know those definitions. Today we're going to do a different theory of acids and bases. It is known as the Bronsted-Lowry theory. You don't need to know the name of it. It's often just referred to, for our sake, as the alternative theory of an acid and base. It basically just explains an acid in a different way and a base in a different way. And it also helps to explain why it is that NH3, which is ammonia, is a base even though it doesn't have an OH. There's no OH in NH3. So how exactly is it that we define it as a base? So the Bronsted-Lowry theory actually defines acids and bases a little differently than the Arrhenius theory. In the Bronsted-Lowry theory, an acid is defined as any substance that is a proton, and we're going to represent a proton as a hydrogen ion. So that's an H+. So an acid is a proton donor. That's how they define an acid. And it defines a base as any substance that is a proton or hydrogen ion, H+, acceptor. So we're not actually dealing with hydroxide anymore when we're talking about a base. We're actually just dealing with H pluses in this definition. So an acid is a substance that is a proton donor, and a base is a substance that is a proton acceptor. Now, if you go to the bottom of page 10, this is going to help you remember that. B-A-A-D. I guess it's BAD or BAD, whatever way you like to say it. But what this stands for is the B stands for bases. The first A stands for accept. The second A stands for acids, and the D stands for donate. And remember, they are donating and accepting H pluses. There's actually no OH minus being dealt with in this one. So bases accept, acids donate. So what we're going to do is we're going to look at this reaction right here, and we're going to identify our acid and our base. And we're also going to identify something called a conjugate acid and a conjugate base. Now, how you do these problems is this looks like an equilibrium problem, right? You have a double-sided arrow. You are going to bracket things together. So you're actually going to create two brackets. The bracket will go from one side of the equation to the other, and there will be two of them. So I'm going to go through the rules and kind of explain how this goes. These are called conjugate pairs. You can draw brackets that connect one side to the other. You can't draw a bracket on the same side. Each acid-base conjugate pair differs by one hydrogen ion only. The acid always has one more hydrogen than the base that it goes with. And this will all make a lot of sense once we do an example. So you're going to draw a bracket to connect one side of the reaction to another. You're going to do that by identifying two substances that only differ by one hydrogen. An acid always has one more hydrogen than its base. You must have one acid and one base on each side of the reaction. Your acids and base are on the left. Your conjugates are on the right. And I'll explain what a conjugate is. The conjugates are on the product side. So we're going to actually label 4 different things in here. We're going to label an A. A stands for acid. We're going to label B. B stands for base. We're going to label Ca. That stands for a conjugate acid. And we're going to label Cb for conjugate base. So I'm going to go through how you're going to do this step by step. So looking at this reaction, the first thing you need to do is you're going to create 2 brackets. One of the brackets is going to connect one pair, the other will connect another. Now, how do you figure out your pairs? Well, you need to look at your substances. So here's my first substance on the left. I need to find which product on the right differs from this by only one hydrogen. And if you look here, here's NH3. I have 3 hydrogens. Here's NH4. I have 4 hydrogens. So I'm going to put a bracket. That's my first pair. Notice they only differ by one hydrogen. All right. Same thing for the water. Here's H2O. I have 2 hydrogens. I look on the product side. Which of these only differs from this by one hydrogen? Well, it's the OH. OH only has 1 hydrogen. So notice they only differ by hydrogens. Everything else is the same. So here's my other bracket. So notice I have 2 brackets. The bracket goes from the reactant side to the product side, and each pair only differs by 1 hydrogen. All right, so then we need to look. Did I lose a hydrogen or did I gain a hydrogen? So let's look at this pair. I went from 3 hydrogens to 4. That means I must have gained a hydrogen along the way. So I'm going to write a plus H plus to show that this NH3 got a hydrogen. It gained a hydrogen or accepted a hydrogen in order to become NH4. Right here, H2O. How did I go from H2O to OH minus? Well, I lost a hydrogen, so I'm going to put minus H plus to show I lost a hydrogen ion. So you bracket, then you figure out, did I gain a hydrogen or lose a hydrogen as I went from reactants to products? Okay. So since I increased in my number of hydrogens going from here over to here, that means that this must have accepted a hydrogen. Now, where did that hydrogen come from? It came from here. So I'm going to write H plus. So the H2O donated or got rid of a hydrogen, gave it to the NH3, and that's how you end up with these products. So this got rid of a hydrogen to become OH minus. This took the hydrogen from that water to become NH3, or excuse me, to become NH4 plus. Now what we can do, now that we know what lost, what gained, we're going to apply the BAAD, bases accept, acids donate. Okay, so let's look at who my acceptor was. NH3 was my acceptor, bases accept. So here's my base. Acids donate. The H2O donated. So here's the acid. Now, each pair, each bracket, so notice the NH3 is bracketed with the NH4. Since this is my base, it's bracketed with its conjugate acid. The acid always just has 1 more hydrogen than the base. Over here, here's my acid. It's always paired up with the conjugate base. So notice, the base and acid is always on the left, not necessarily in this order. The conjugates are always on the product side. A base is always bracketed with a conjugate acid, an acid is always bracketed with a conjugate base. You figure out what the base is by if it accepted or donated a proton, a hydrogen ion, and you do that by looking at how many hydrogens are in the pair. So we're going to do a couple more problems, and I know it's really a lot at once. And we're going to do this by, on page 11, looking at water. Water is actually super special. Water acts as an acid or a base, depending on what it's with. And we're going to do 2 examples and practice doing the conjugate and all that stuff. Okay, so here's our first example. We're going to write this down. So I've got H2O, which is water, and I've got HCl, hydrochloric acid. I'm going to draw a double-sided arrow. I get H3O plus, and I get Cl minus. Okay, so our first step whenever we're doing conjugate acid-base pairs is we need to pair up the 2 pairs. So we're going to look at our first substance, H2O. Okay, here's H2O. I need to go to the product side now. I need to find out which of these differs from H2O by only 1 hydrogen. No other elements, just a hydrogen. So if I look here, H3O is exactly the same as H2O, it just has 1 more hydrogen. So I'm going to bracket those together. So there's 1 pair. The bracket always has to go from the reactant side to the product side. HCl, that means that HCl should be bracketed with Cl, which makes sense. It only differs from HCl by 1 hydrogen. So I'm going to bracket those together. Once I bracket them together, I need to figure out, going from my reactant to my product, did I gain or did I lose a hydrogen? So I went from 2 hydrogens, and then now I have 3. So that means I must have gained a hydrogen. Let's look at the HCl to Cl. I went from HCl, which is 1 hydrogen, to no hydrogen. So I lost a hydrogen ion along the way. Now, all the trading of the hydrogen ions goes on the left side. No trading goes over here because this is your reactants. These are just what you end up with after that proton has been donated or accepted. So once we figure out what lost and what gained, you want to remember BAAD. Bases accept, acids donate. All right, so since this went up in hydrogens, it went from 2 to 3, it must have accepted a hydrogen, and it accepted it from the HCl. Okay, bases accept. So that means H2O is my base, acids donate, HCl must be my acid. Once you figure out what your acid is and what your base is, you can figure out the conjugates on the product side. My base always goes with the conjugate acid, and the acid always goes and is bracketed with the conjugate base. Now this is an example where water, H2O, acts as a base because it is accepting a proton or a hydrogen ion from HCl, which is a strong acid. All right, let's do a second example using water. All right, for this one, we're going to do okay, same thing as before. What you're going to do is you need to look at your reactant and find a product that it differs only by 1 hydrogen. So if I look at H2O, out of these 2 products, this is the one that is only off by 1 hydrogen. So these are going to be bracketed together. There's our first conjugate pair. And NH3 and NH4 only differ by 1 hydrogen. So there's our second conjugate pair. Now what we need to do is figure out, going from reactants to products, did it gain or did it lose a hydrogen? So H2O, there's 2 hydrogens, and now I only have 1. So that means I lost a hydrogen ion along the way. Going from NH3 to NH4 plus, I gained a hydrogen ion. Remember, all of the trading of the hydrogens goes on the reactant side. Nothing happens over here. So since this lost a hydrogen, and this gained a hydrogen, this must have given its hydrogen ion, the water must have given its hydrogen ion to the NH3 for that to occur. Remember, BAAD, bases accept, acids donate. Since the water donated to the NH3, it is the acid. And since the NH3 accepted that, it is the base. So remember, our acids and our bases are always on the reactant side. The conjugates go on the product side. So our acid is always paired up with its conjugate base. Can never have an acid with a conjugate acid bracketed. And then here's our base. This must be the conjugate acid. Notice when water is with a base, such as NH3, it acts as an acid. Sometimes when it's with an acid, it acts as a base. So water can actually act as either an acid or a base. I'm going to give you 2 practice problems down here, and I want you to try them on your own. I want you to identify the acid, the base, the conjugate acid, the conjugate base, all that good stuff. So here is your first example. We've got HClO4 plus H2O, double-sided arrow, H3O plus ClO4 minus. And then your second example is going to be, let's see, H2CO3 plus OH minus, double-sided arrow, HCO3 plus H2O. Okay. So pause the video, try these 2 practice problems. I'm going to kind of fill these in for you after you're done. All right, so first step whenever we're doing these, what you need to do is identify your conjugate pairs. So HClO4 goes with ClO4 because they differ by only a hydrogen. So I'm going to bracket those together. H2O goes with H3O plus because they differ by only a hydrogen. Remember, you can't put brackets on the same side. It goes from reactant to product. Second step, you need to figure out going from for each pair, did you gain or did you lose a hydrogen ion? So for HClO4, I must have lost a hydrogen along the way. So I'm going to put a minus H plus. And for the H2O going to H3O, I started with 2 hydrogens and now I have 3. So this must have gained a hydrogen along the way. All the gaining and accepting goes on over here. So since this went up in hydrogens, it must have accepted a hydrogen from the HClO4. This is where you want to remember BAAD. Bases accept hydrogen ions, acids donate. Since HClO4 is the donor, it's the acid. And since H2O is the acceptor, it's the base. Now what we can do, here's our acid. That makes the ClO4 the conjugate base. And since this is our base, this makes the H3O plus the conjugate acid. All the conjugate acids and conjugate bases are on the product side. Good. Let's try this one down here. First step, bracket your conjugate acid-base pairs. Remember, they only differ by 1 hydrogen. So here's my first conjugate pair, because it's 2 hydrogens over here and 1 there, and everything else is the same. Here's my second pair. All right. Going from H2CO3 to HCO3, I lost a hydrogen ion, so I'm going to put minus H plus. Going from OH minus to H2O, I went from 1 hydrogen to 2, so I must have gained. Okay, so the OH gained a hydrogen and this lost one. So this donated to that. Remember BAAD, bases accept, acids donate. The H2CO3 donated, so it's an acid. The OH minus accepted, so it's the base. Our acid is always bracketed to its conjugate base. Whoop. And the base is always bracketed to the conjugate acid. If you go through those steps, you should be fine. Remember, all the donating and accepting goes on the reactant side. The products are just what you end up with after. So it's a lot easier to tell if you who gained and who lost that way. All right, so Monday we'll review a little bit more, and on Tuesday you'll have your quiz. There will be a skill check on Monday as well. Have a good one.